Greetings! First of all, Happy New Year to all my subscribers. Today I've received a package in the mail. The postal service has been off for a week and I haven't received anything in that week, and we're starting to get a little bit desperate for something to assemble. Well, I have got a kit in this package in front of me, but it's not what I thought it was going to be. It's not my power supply modules, but it's actually another kit I ordered, well actually a lot later than I ordered the power supply modules. This is a little 4-digit LED clock kit, which features a blue display and its own acrylic little case to put it in. And this got here sooner than well, I haven't even received the power supply units yet. What I find interesting is this mailing address. Air Planner, Laos Site, Co Limited, blah blah blah. PDR. I'm not sure where PDR is. Anyway, let's get the package open and we'll have a look at the contents. Bubble wrap! Awesome! I love bubble wrap. Yeah, well, whatever. That wasn't very exciting. There wasn't very many bubbles to pop. Okay, let's see here. Plastic bag. Ooh. Yeah, well, when they said it was a large digital clock, they weren't kidding. I'm not sure how much they measure. Let's see here. Okay. About 15 millimeters. So the size of these LED segment displays is about an inch. So anyway, let's get this bag open. I suppose I could just use a pair of scissors on the plastic here. So there's our casing parts, which I will leave all the fun bit of pulling off the backing paper to last, so I'll put them to the side. And we've got a bag of components. I'll keep this polythene bag because they'll come in handy for something else. One of the display modules decided to come off. Oh, they've got a piece of diffuser paper, so it diffuses the LEDs. It's not cut very straight, but I'll stick that somewhere safe. So there's our 7-segment displays. Here's our 8-pin dual inline. I think that's 24 or 28 pin. I'm not going to sit here and count the pins, but that's for our processor. And on the back here we have a processor chip. So according to this board, the processor is actually an STC15, and it looks like the other one is a DS1392 by the looks of things. A little disappointed that it's just stuck in a piece of polystyrene foam, not actually an anti-static piece of foam. I mean, they could have just stuck a piece of tin foil over the top of the foam and shoved, you know, the ICs into it, but yeah, right, okay. We've got a USB to, I'm not sure what size that is, it's probably a 5mm with a 2.1 center. Power adapter, so that can run off of a USB port of a computer or one of these. A phone charger, which has a USB outlet on it, and I got these free. What the actual output rating of that is, I'm not sure. Look at it under a microscope, well, magnifying glass I should say. Okay, it can handle an output of 5 volt at 700 mA. So yeah, it wouldn't even be using the 12 volt rail, it'd be using the 5 volt rail. And I think 700 milliamp would be more than enough to power this clock kit. We don't need those at the moment. Continuing on, we've got another bag of components, transistors and resistors and power socket and switches and stuff. And another little bag, and that's the end of that, with some mounting hardware, so some screws and some bolts and nuts. Right, and this would be the instruction sheet. Oh, they even give you a little schematic, that's nice. Yeah, it's using an SDC processor, and yeah, this looks like just a crystal oscillator, the 8-pin dual inline. IC is just a crystal oscillator clock provider to provide clock pulses for the CPU. And of course your display array with 4 separate driver transistors on the commons, I believe. I think these are common anode. Yeah, they would be because they're PNP transistors. And there's a little buzzer down here which is for the alarm settings. But I might have a quick read of what the rest of this says and get back to it. Okay, so most of these instructions, if you want to call it that, is just telling you how to set it up after you've built it. Because step 4 over here says insert IC at last and install lithium battery and get power on with 5 volt power output. That's bad English. I don't actually have a lithium battery. I'm not sure what size it took now. I'll have to have a look at the ad. It's only a small battery, so it's a 3 volt lithium, like a CR2 something or other. Doesn't even say what it takes. Yeah, so anyway, I'm going to have to reread the ad on eBay to find out what battery was required. I haven't got one, I'll get one later. Because it's going to be powered up off of USB, or this power adapter, I don't think a backup battery is all that important just to get the thing working. But it would be handy to get one, so I'll just go look up what the actual battery was supposed to be. Okay, so it takes a CR1220 for those playing at home. So as I say, I'll get one later, which means I'll have to, after I've assembled the board and assembled it in the case, I'm going to have to take it apart to put the battery in. Well, you'd have to take it apart to change the battery anyway. But that's getting beside the point at the moment. So these instructions really aren't going to be very helpful to me, because most of the stuff is written here on the silk screen of the circuit board, so that's the same as that. So I don't need this piece of paper at the moment. So I'm going to mount this in the helping hand thing and stop saying the word so, and get on with some soldering. I just hit this sponge that's in the bottom of this with some water, and it's actually expanded twice its size. That was like kind of cool, because it was like erect, standing to attention. Yeah, anyway, put that down there. Now it's going to be very difficult for you to see what I'm doing with this magnifying glass and the Y, but I'm not going to really do a time lapse of the assembly or anything. I'm just going to show bits of the time. I'm going to first start with the easiest and smallest components first, which is resistors. Yeah, resistors. There's 2 sets. One's 10k, one is 330 ohm. There's also a little tiny diode here, which I think is just a normal silicon diode. So there's not many components to install, but I'm going to start with the smallest components first, which is the resistors, and then we'll come back. Because now I can actually see how good my solder joints is without having to stop and pick up a magnifying glass every 5 seconds. I can actually look at the thing while I'm soldering it, although it does take a little bit to get used to. Actually, I might use, no, it's not going to fit. I was going to stick it, the roll of solder on that extra arm, but I don't think I will. And there was a comment in one of my videos about this helping hand, that this extra alligator clip thing here is for actually holding wire whilst tinning it, which actually does make perfect valid sense. So that's probably what it's for. Okay, I've got the first three 330 ohm resistors installed. I'm just going to keep continuing like that until I get the rest of them installed. And this is how fancy this is. You can just do that and rotate it. It's lovely. I just realised after all that I didn't have much light in here. You've got to remember that when using a camera they require quite a substantial amount of light to operate correctly. And I've also moved the camera to a different angle rather than directly over the top, because you can't see anything with this in the way. So I just moved the camera to the side of me. And if you like these sort of videos of me just putting components in a board and just waffling on about random crap, then just let me know. I suppose there's some entertainment value in it, at least, well, someone's talking to you, I suppose. And if you share the same passion as I do for electronics, well, yeah, listening to any type of conversation whilst assembling a circuit board is probably quite nice. So I'm down to the last two 330s, but I can't see anywhere else on this board where another 330 goes, so I've got an extra one. So if you buy this kit, I will put a probably an inset in the video and a link to the eBay article for it. If you get this kit, you're going to end up with one of these 330s over, and probably a few 10Ks by the looks of things, because there's only 7 used and they've given me 8. Same as there's only 7 330 ohm resistors used and they've given me 8. I mean, I'm loving the fact that this thing has a light on it. The only problem is, so I can actually see what I'm doing, I've got to close one eye. I still can't quite see properly. I suppose it's just a matter of getting used to it. Okay, that's those 7 330 ohm resistors installed. I'm just verifying that it's been soldered correctly, which it has. Now let's trim off the excess leads here. I really should have a bin next to me, but I don't. Okay, now I'm going to move on to the 10K resistors, and it's pretty much the same procedure. I'm just going to put them in where they go on the board. Not sure what it is, but there's something very therapeutic about putting components into a board. Maybe not so much therapeutic, maybe more satisfying, I should say. I can't even talk at the moment. I've got the last 2 to insert here, then I can solder them. And I'm actually putting all my bands around the same way, so when you read them, you're not having to turn the board around to read the colour codes. It's just the way I do things. If these were like the micro resistors that are only about, you know, 1/4 of an inch long in their body, those I usually wouldn't worry about trying to like look under a magnifying glass to put them the right way around. I mean, they're not polarized, but it just looks a little bit more professional if the bands are all reading the same way. And if you've got like a capacitor next to a bunch of resistors, you put that capacitor's label side facing the same way as you would be as you're reading the resistor left to right. But that's just the way I do it. Just trim off the excess leads. This magnifying glass is awesome, apart from when it has a little bit of an erectile dysfunction. Tighten it a bit better. That's the quartz crystal, so that needs to mount flat to the board. So that goes where it says Y1, so you just, these aren't polarized, they shouldn't be anyway. I've never seen a crystal that's been polarized before, except a crystal filter, but this is just an ordinary crystal, so it should be able to go in any way around. So I just poke it through the board like that, and then just bend it over flat, and then solder it. Okay, after examining the circuit for a while, we've got two extra resistors. This is a light dependent resistor, if the camera will focus, or LDR, that detects the level of light and changes its resistance. This what I thought was a diode. I think this is actually a PTC, or positive temperature coefficient device, because this also can sense temperature. You know, because these instructions are in Chinese, well, the schematic is anyway, it makes it awfully difficult to figure out what parts are what, but I know that this is an LDR. So because I know it's an LDR, that goes in position R16. So I'm going to put that in now, because I can. This would be used for dimming the display when it's dark, I suppose, and then be brighter when it's during the day. Now these shouldn't have a polarity on them either. So that weird diode looking device I'm going to leave till last. Next I'm going to move on to, well, I guess, mounting the ceramic capacitors that we've got. We've got several different types here. That is unreadable. That's a 0.01 microfarad. So that goes in there in C1. As I said, I'm going to put the label side of the capacitor facing the same way as the bands on the resistor next to it are. It's just the way I am. So I'll solder that one first so there's no confusion, because there's 4 in total by the looks of things here. So you want to make sure you get the right capacitor in the right place. This thing's come loose again. I just burnt myself. Okay, that's one capacitor. There's no electrolytic capacitors, I've noticed. That's a 22 picofarad, so you go there. There's actually 2 of those, probably 3 actually, I think they're all the same. So I'll just load them in. I guess the therapeutic thing about this, that is also a 22, so there's 3 of them. For putting components through a board is it's the satisfaction of seeing something finally coming together. and I cannot for the life of me see where that capacitor goes. So they've given us too many capacitors by the looks of things. Indeed they have. So we don't even need that capacitor. Okay, so those capacitors are installed now, so I might move on to the transistors. I think that last diode looking thing is actually a thermistor, but I'm not actually sure where it goes because the instructions are unclear, and quite frankly I do not really need temperature sensing abilities, but I can always install it. It looks like all 4 of these transistors are the same, so I'm just going to bring them as close to the board as possible. Don't want to go too far with it. With the thermistor, it's a debate of sticking it in position P3 or R17. So yeah, that's the issue I'm having as to where it's supposed to be installed, and because the text underneath the device is Chinese, and I can't read Chinese, I don't know what it says. It could be telling me to F off for all I know. No, not really. It'd probably be saying like something for R17 might be the thermistor. I'm actually going to go out on a limb here and say that position R17 is for the thermistor. That is where I'm going to insert it, and hopefully it's right. If it's not, well then it won't work. But it's not a polarized device either, so it doesn't matter which way around you insert it. Right, so yeah, I suppose with this device I'm going to call that the thermistor, and I'm going to stick it in position R17. If we look at the schematic here, you can see R16 is the light dependent resistor, and over here is what looks like a PTC symbol. So yeah, that's where I'm going to stick that device, is in position R16, which is going to be fun because it's only a 2.5mm spacing and it's a bigger component than that. So I'm going to have to get creative. And I've lost my pliers. My pliers! Oh, right in front of me. Why didn't you tell me it was over there, guys? I've decided now I'm going to stand it up at right angles. That would look a little bit neater than the way I was trying to do it. Something like along the lines of that, but I'll leave a little bit of lead on there. Okay. Flip that over and solder that. Okay. Done. Trim the excess. I've got a nice pile of offcuts on the desk now. Nice little pile of offcuts. So for those playing along at home, this is how the board should look so far in its assembly. The 3 capacitors installed, the 14 resistors installed, and the 4 transistors installed on the crystal oscillator, the LDR, and the PTC. So I'm basically just moving from smallest components to largest components, leaving the display to last. Next component I'm going to mount, I would say, would be this thing that I just dropped, which is the battery clip. And so far I'm mounting everything to one side of the board. Wherever there is a outline of a component is where it mounts, because the 7-segment displays mount on the opposite side of the board, which actually is what all these extra header pins are for. It's for the display segments, which makes absolutely perfect sense. Now, this is going to be fun to solder because it's not going to stay there. So I haven't got enough material there to actually bend the lead over, so I'm just going to quickly tack one end whilst holding it with my finger, and then I can solder the other side and the one I just tacked properly, because that balled a bit. There we go. That battery clip is installed. I really do need to get hold of a CR1220 battery, but yeah, and I've mounted the little tab which stops the battery coming out any further towards the transistor, so you're slipping the battery in from the side of the board, which would make perfect sense. Now I suppose it would be a good time to mount the IC sockets, so I'll do that next. And there's a notch marked on the overlay and there's a notch on your IC socket, so that indicates where pin 1 is, and pin 1 is a square pad on the board. So I'm just going to insert the processor IC socket first and make sure all the pins are straight, because if one of them's bent it's not going to go in. Right, so that looks like it's straight now. There we go. And, well, I'm just going to bend over each corner of the socket, so when I turn it upside down it stays there. Whilst I solder one pin, and solder the next, and then I'm just going to keep going down the line. Okay, so now I'm just soldering in the last IC socket. I've pretty much done the processor's IC socket. Now I'm just moving on to the clock pulse generator IC, oscillator. So I think that's soldered. Perfect. And now we have something that looks like that, which I think is awfully sexy. Okay, there's, well, 3 largest components left. I'm going to install the buzzer, the noisemaker, and on the top here you'll notice that there's a marking on the little label you've got to pull off saying positive. That pin on that side is the positive, so that goes after I straighten this round. And also one lead is longer than the other. Don't know how well you can see that, but the shortest lead is the negative. So I'll pop that in the circuit board and just slightly bend the pins a bit, turn him over and solder it. Next thing to install are these 2 tactile micro switches, and they poke out from the edge of the board over this side, so they just go through the holes like I've just done there. See how the ends of the switches here are on the edge of that board, or edge of the board. So this is going to be a little more fun to solder. So I'll just bend over that lead there, one of the casing leads. Same there, just to hold it. Yeah, that'll do perfectly. Got it soldered over. So I've just done one corner. I'm just giving each switch a push just to make sure it's square with the board. hot flush with the board, I should say. And it's just a matter of soldering each terminal. Now the last large component to install is this DC socket. So I'm going to flip that over. That goes over here next to the battery. And again, one edge of it obviously comes out the side of the board there. See how it comes out the edge of the board. So this one shouldn't be too hard to solder. Each display has a decimal point, and it's marked on the overlay here where the decimal points here and here go. And this one's reversed, so these two decimal points would form a column, and the last decimal point is facing that way. So the first one, which is on the opposite side to the switches, the same side as the DC socket I have soldered, the decimal point is here. The same is true for the one next to it. Only one of them is mounted the other way around, which is DS3. So that's the last bit to install. Okay, the pins on the DC socket were getting in the way, so I just reheated the leads and bent them a bit over. So remember, as I said, that the decimal point on this third module goes in the opposite direction to the one next to it. And finally we get the last fourth one, and the decimal point goes back the same as the other three. So we should end up with something looking a bit like that. We can pull this thing off the beeper. That's the assembly of the board complete. Now I suppose it would be a good time to stick the oscillator IC and the processor IC into their relative sockets. Suppose I'm going to plug it in and see if it either makes a noise and lights up, or both. So grab the USB cable here, plug it into my phone power adapter, plug this into the power. Oh well, we've got a display. It says 001. Right, well, that's helpful. Oh, well, it says it's 22 degrees Celsius apparently. Well, it did. 22 degrees Celsius. So I was right, I'm touching the PTC now, it says it's 25 degrees Celsius, so that's where it goes. So that's cool. So it's actually 143. I still don't know what that is. It might be a GMT thing. That's pretty cool. So now I need to assemble the case and yeah, go from there. I might want to try and buy, actually now whilst I'm thinking about it before I put it together, is a CR1220 battery. Anyway, we'll be back shortly. Okay, and as you can see, it's a short time later, about 45 minutes have been out. Bought a CR1220 lithium battery, and the clock is still going. It now says it's 19 degrees Celsius, so I'm going to do a heat test on the ICs, and they feel cool, so they're not over hot. Neither is the power adapter. So yeah, the clock is still working. Now I need to insert the battery. Now the thing about these batteries is, it's not a good idea to actually touch the battery with your fingers, because the oil on your skin can actually destroy the battery, either flatten it, short it, or shorten the life of the battery. So wear a glove on your hand when inserting the batteries. Doesn't matter if you're removing it, but if you're inserting a new one, put a glove on or just a plastic bag. There we go. It's just a freezer bag. Now, I would assume that where the battery goes in, which is over here, the positive is on top and the negative is on the board. Because if we look at the lithium battery, the positive is the large area of the battery and the negative is the smaller bit on the other side. So I'm pretty sure and confident that it goes that way round. I've just had a look at the schematic, and the negative side of the battery should be on the negative side of the DC socket. So if I do a continuity check on the outside sheath of the adapter is the negative, so if I untwist my leads, I put negative on there and there, we have no continuity. I'm not going to be able to get into where the negative part is on the board, but I know that that is isolated from the negative of the plug. So as I said, the way I said to put it around, this side is the positive. I now just insert it like that. Now the battery backup is installed. So that means I should technically be able to unplug this and it'll keep whatever time was there if I plug it back in. And it does. So I definitely know, even though that's upside down, I definitely know that that battery is in the right way round. So now we can move on to assembling the next part, which is the plastic acrylic case. And because I'm almost finished completing construction, time to open a beer. Happy New Year! Okay, so we just opened the bag. Pull out all the parts we need. We are also going to need mounting hardware. Now, there's no instructions on how to assemble the case, so I'm sort of playing it by ear here. I'm going to remove the backing tape off of all of the pieces. Of course, I'm not going to shoot video of doing that because, well, what's the point? Last piece. I think the hardest part of the assembly is actually getting this backing tape off, because as soon as you start getting a bit off, you pull it and it rips. So you have to keep on picking at it to get it to, so you start and it just rips. That's because of all the holes and stuff cut in the acrylic. I mean, this backing tape is what comes on the acrylic when it's manufactured in the first place. And of course they just cut it out with the backing tape still left on it to protect it, which is perfectly fine. But when they've been sitting a while, they tend to make it difficult to get the stupid stuff off. I suppose you could wet it first, that might help. But, bugger it. It helps to, bollocks, it helps to have fingernails. But yeah, I think the most tedious part of this is pulling this frickin' tape off. So there's all the pieces there. That looks like the front, that looks like the back, because there's a, don't know if you can see it, but there's a hole drilled in it, which I believe is to allow the piezoelectric speaker to emanate sound from. Now, there's a slot cut here, so I'm not sure if that's the top or the bottom yet. There's another one similar with no slot on it, so one of these is the top and the bottom. And these two are the sides. The one with the two holes in it is for the tactile switch side, and the one with the large cutout here is for the power adapter to plug into. And you'll notice there's all these little cross cutouts in them. Those are to hold the nuts from in here into it, and then you put a screw in from the other direction. There's a tiny little hole through there, and there's one down here for the bolts to go through, so it might be better to put the bolts through the holes. And of course I'm doing it the hard way. What would be probably easier is to put the nut on the end of the screw. That'd probably work out a little bit easier than what I was trying to do. And then when I join the two halves together, the two parts I want to join, albeit it keeps moving around, I can just put my screwdriver in, and there we go, one piece is in there, not straight, but it is now. So I'll just tighten him up. So I've got a panel on, I'm not sure if it's the bottom or the top yet. Now I'm going to mount a side. Now, depending on which I choose to be the top or the bottom, I don't think it really makes any difference. There's no little cutout in the circuit board here for it to hook into to stop it moving around or anything, so you don't have to worry about that. But what I think that hole is for is to allow well, air into the temperature sensor and the LDR a bit. So I'm going to use this as the top, I think. I'll remount this side panel. That's actually starting to look quite sexy. Okay, so now it's time for the front, and we can't forget about our little diffuser. So I'm going to put that in. Make sure it's at least semi-clean. As haggard as that looks. Okay, so I've got to put 2 screws, and they've given me an extra screw by the looks of things because I've got 3 of them. And I only need 2. Right, so that should be alright to do up now. And it's got a little thing on the bottom of it which makes it prop up a bit, so that's kind of cute. So I've got this last side to do. And there. Plug it back in. And with the diffuser on it now, it's a lot more readable, even though it's upside down to you. I'll turn it the right way up. There we go. It's now 14:58 or 2:58 in the afternoon, which means it is about 4 minutes slow. That's alright. Okay, now reading the instructions, this is how we set it up. Part 5 of the instructions says press the function key, which is this one up the top, and the plus button or set button together and hold it for 5 seconds, and that should reset everything and it should beep. There, well, it didn't actually beep, it said 7:59, then it should go 8 o'clock. That sounds terrible. Okay. Now, set the time and alarm clock and hourly chime. So to set up hour, press the function key. The hour will flash. Then we change this to revise the hour. So it's 3 o'clock. Well, it's 3 something. It is 3:10, we'll say. Set up the minute, press the function key, minute should flash. 10. Then to set the hour of alarm clock, press the function key. So it's set for 7. I'll leave that set to... how far can that go actually? Is that in 24? Yes it is. So what I'll do is I will set that for 3. Oh, it started to go. I'll set it for 3:20. Okay. Well, the instructions are confusing because it's written in Chinglish. What if you want to turn the alarm clock off? So this is confusing as hell. Now this thing's got an hourly chime. So press the function key. The hour digital tube is blinking. Press the plus key to revise the starting time of the alarm clock. Oh, okay. That would be for the hourly chime, when it starts. If you adjusted it to 9, then it will start an hourly chime from 9 AM. So the second part of that is when it stops chiming, so we can set that to say 8 o'clock at night, which is 2000. So then we press that, and then if you turn it on, so if point 3, which is this one here, comes on, if you press the plus button, that means the hourly chime function is on. Press function key to exit and the setup is done. Don't know what that -2 thing is, but yeah. So I've set up a alarm for 3:20 PM, so we'll see if it goes off. And just for shits and giggles, I might actually change the time closer to an hour, like closer to 4 PM, and then see if the hourly chime works. And yeah, go from there. And then I'll obviously reset the time back to what it should be. I'm not sure what that 8.05 means. Oh, the excitement, the anticipation. Yeah, right. Okay. That buzzer sounds like crap. Okay, so that's the time. That's the alarm. That's that setting. Let's find out what this is. I think that's a date. So we're the 2nd of January. So that's a date. Just in case anyone was wondering. I'm not sure what that's for. I'll leave it at -1. That's the time. That's the degrees. So I think that's to bias or adjust the actual temperature. And after looking up what the current temperature is, it's around 20. Well, I've got a fan going, so I'll leave it at 22. So that's our time. So I'm going to change that to closer to 4 o'clock and see if the hourly chime function works. Close enough. Now the only problem with that date function that it displays, it uses 31 days for every day of the month, I think, which is wrong in February when it has 28 and 29 on a leap year, and when there are 30 days in September April, June, November. Okay, that sounds absolute crap, so I'm going to turn that function off as well after I reset the time back to the correct time, which is 15:24. That's the alarm, so we ignore that. Turn that off. And I don't want the chime anymore, so we'll turn that off. So there we have it, the do-it-yourself 4-digit digital clock kit from eBay, around about $7. I will put a little link in the description to the kit where I found it, and yeah, it'll be different prices in different countries. So it's very easy to build. Total component count that you've got to assemble is probably about 30 components. It's not that difficult. It's just a bunch of resistors, a few capacitors, a battery holder, power adapter, which is a bit crooked now, but yeah. Don't know if I mentioned before that when you install that power adapter, you've got to bend the pins over to allow clearance for the first 7-segment display to sit in there properly, or else it's going to sit up at an angle. I had to actually go back in there, reheat the joints and bend them over, which is why the socket ended up a little bit crooked as it is now. But other than that, it looks quite neat as it is, and will look probably really great next to my bed. Unfortunately, the alarm buzzer sounds like absolute shit, so I won't be using it, but it's great just to see what the time is. Anyway, this is the Astro 30 saying thank you for watching, and if you want to follow me on Facebook and Twitter, you can. The links are in the description as usual. Anyway, this is the Astro 30 saying see ya, have a great day. Happy electronics and Happy New Year.